Hey guys, this is the second day of integration by parts, and this is where I get to show you a shortcut. So we're going to do like a recap and then show you a shortcut. So again, you've got the formula, you've got the steps, and then here's a summary of like common helpful hints. If you're doing an integral of the form, now notice, each time we've got two things multiplied together. Anytime you have your variable to a power as one of the things that are being multiplied together, variable to a power, variable to a power, they're saying let u be that variable to a power. Let it be your x squared or your x to the first. That's what I told you yesterday. However, if you have a variable to a power and another piece is a logarithm, the suggestion here is don't let this be your u, let your log be your u. Interesting, because when you do a derivative on it, it's going to turn into 1 over x. It also says, so basically it's saying let logarithms trump x to the power when you're picking a u. They also say let any trig inverse trump your power when you're picking a u. And then the suggestion here is kind of backwards from what I did yesterday, but either way, it was we were gonna start developing a loop either way. So this turned out really funky when I put this in Notability. But this is just kind of a checklist. When choosing a u, let your u, if you have this type of function, let that be your u. If you have this type of function, let that be your u. Now here's what they are. The L stands for logarithms. So that's going to be your first choice in picking a u, any kind of logarithms. Your next, this is not going well. There we go. Your next one is going to be inverse trig. So if you've got any inverse trig, and I doubt you will, I'm not going to do that to you. If you've got any inverse trig, let that be your u. If you've got any algebraic expressions like x squared, let that be your u. Next is any trig. Let that be your u. And they're saying exponential, that should be your last choice for choosing a u. Okay, now, moving on. Got two problems on the back. Check this out. Both of them involve like an x squared. So in doing this problem, I would let u be x squared, and I know automatically I'm going to need to do 2 rounds of integration by parts. Same. I would let u be t squared. I'm going to have to do 2 rounds of integration by parts. You all know if that was t cubed, you would have to do 3 rounds of integration by parts. And I know you don't really relish the thought of doing 3 rounds of integration by parts. So I'm going to show you a trick. It's called tic-tac-toe. And I'm going to start with this one first. So here's what I'm going to do. I don't know if you remember this, but yesterday as I was saying, pick a u, pick a dv, I was using blue for u and red for dv. So what I'm going to have you do is I'm going to have you make a table with 3 columns. Your first column is going to be u. And in this column, we're going to do derivatives on u. Your next column is going to be your dv column. Here's where we do antiderivatives. And your last column is going to be for signs, S-I-G-N-S, signs. Okay, so for our first row, we don't really, you can leave this empty or you can say plus minus whatever. This isn't really going to count. So we're going to kind of leave that. In fact, we can leave it, let's just leave it blank for now. All right, so pick a u. In this problem, I'm going to choose u is t squared. Now here's what I want you to do. So your first row is t squared. It came straight out of the problem, which means your dv has to be everything else. But you don't even have to write dt. You can just write e to the t. And here's what I want you to do. Keep making new rows, doing derivatives on your u's until you get to 0. So the derivative of t squared is 2t. That's my next row. Do another derivative on that, which is 2. Do another derivative on that, which is 0. Keep doing derivatives on your u's until you get to 0. Now, dv, these are your antiderivatives. So you need to keep doing an antiderivative for as long as you did derivatives in this column. So this is kind of cool. The antiderivative of e to the t is e to the t. E to the t, e to the t. That was cool. All right, now, your signs are going to start a row below. So leave this open here. And then your signs, you're going to go positive and then alternate. Start with positive, alternate until you run out of rows. And now I'm not really sure why it's called tic-tac-toe because it's not a true tic-tac-toe, but here's the thing. Here's how we come up with your answer. We say tic-tac-toe. So my first term is t squared times e to the t, and it's positive. My second term is 2t e to the t, and it's negative. My third term is 2e to the t, and it's positive. And don't forget the c. You like it? This one's a little bit harder just because it's going to be a little harder. Instead of sine of x, you've got sine of something messy. So we're just going to have to use our brains just a little bit to try to do some quick antiderivatives here. But you'll get it. I know you will. So we're going to make a u column. This is going to be our derivatives. You don't have to label it if you're kind of getting the hang of it with derivatives. You're going to make a dv column. These are going to be our antis. And then signs. U, dv. Okay, a little tricky. So, I need to do an antiderivative on sine of 4x. If we were doing this antiderivative on paper, if we were doing this integral, I would use u substitution, and I would say, okay, this is messy. U is 4x, du is 4. Ooh, I am missing the 4. Let me put a 4 in and a 1/4 on the outside. That 1/4 on the outside is very important. So basically, when you do an antiderivative, it's going to need like a 1/4 on the outside to balance it out. So let's see, derivative of cosine is negative sine. So this is going to be negative 1/4 cosine 4x. If you're like, what on earth did she just say? Just do a real quick derivative. I think you'll get it. The derivative of cosine is negative sine. Okay, so this is a negative. We got a negative sign, which turns it positive. And then remember, you would chain rule this. You would take times the derivative of the messy. That's where this 1/4 came from. Now, when we do it again, we're going to need another 1/4 out there. So the antiderivative of cosine is sine. So derivative of sine. So it's negative again, and now it's 1/16 sine 4x. And then another antiderivative, let me think, derivative of cosine is negative sine. Okay, so it's going to be a regular cosine, and another 1/4 makes that 1/64. And then leave the top row blank for your signs and go positive, negative, positive. You're going to start with a positive, and then you're going to alternate as far down as you need to go. And then you're going to go tick, tack, toe. So I'm going to write, it's saying it's positive. So basically you got a positive times a positive. No, basically you've got a positive times a negative, all right? So our first term is negative x squared over 4 cosine 4x. You okay with me? You okay with that? X squared times 1/4 is negative. And then the next term, a negative times a negative, is a positive. So that's going to be a plus. And I need 2x times 1/16. That's going to be x over 8 sine 4x. And the last term, positive, positive, 2 over 64 is 1 over 32. What'd I do? I did something wrong. I should not have 2 signs in a row. Y'all can't stop me when I'm on a video. Okay, so my red antiderivative was, this is, cosine. Derivative of cosine is negative sine. I wrote that wrong. I think I said it right. And I just wrote it, I don't know. Is that what y'all had? Let me check. The derivative of that is negative sine times the derivative of messy for, yeah, that looks right. Okay, so where am I? 1 over 32 cosine 4x plus c. The tic-tac-toe method.